today is more about, we start with the graph and then we write the equation from the graph. And so today's going to be a little bit more about recognition. Okay, so I like to start with recognizing the sine curve first. That's just my comfort zone. So if we start with that and then we go like, we don't like looking at the sine curve first, then we can look at the cosine curve if that's what you guys prefer. Okay, if we find out that's what you guys prefer. All right, so what we're going to do is we're going to write a sine and a cosine equation for each of the following. We're going to make sure we mark where we're starting from, because what happens with these is there's a lot of different ways you could write the equations of these curves, depending on where you choose to have the curve like start from, because one part of the equation is the horizontal shift. So if I say the curve started right here, that's going to be a shift to the right. If I say the curve started right here, that's a shift to the left. Do you guys see the difference there? Over here, this would be a positive curve, right? Because the first part of the wave goes up for the sine curve. If I said the curve shifted to the left, then this would be a negative curve because it would be down first. So it makes a difference if you start the curve in one place versus another, which means that for every curve that we draw, there are infinitely many ways you could write the equation, and we are just choosing to write it one way, which means one table is probably kind of working together, comparing answers. They might have one set of answers for a problem that are all kind of the same, and the table right next to them might have a different set of answers because they chose to look at the graph a little bit differently, and everybody's correct. Does that make sense? When we are working on these, everybody kind of writes their answers as the stuff that starts around where the y-axis is, but technically somebody could start their graph somewhere over here. It's just not as likely. But they could do it if they wanted to. Okay, so what I'm going to do is I'm going to take one of my markers. It doesn't matter which one. I'm probably going to use the lighter color because for my second equation, I'm going to draw on top of this. But I'm going to start with my sine equation. I'm just going to start right here. And I'm going to draw the full curve for a sine equation so that I can see just where it starts, goes up, does a full loop, goes down, does a full loop, where it stops. And I'm going to fill in some information about this because that's going to help me write my equation. So can you guys tell what the amplitude is? 3. So it goes up 3, it goes down 3, so my amplitude is 3. The graph starts right here at pi 6. It ends at 7 pi 6. So if we do 7 pi 6 minus, minus 1 pi 6, what does that give us? 6 pi 6, right, which is just pi, okay? And it's shifted to the right. So if we think about the formula that helps us find the period of the graph, what's the formula? 2 pi divided by b. So you're going to do 2 pi divided by b equals the period of pi, and I want you guys to solve for the b value. So the period of the graph is pi. Did anyone figure out what the b value is? The b value is 2. Okay. Is there a vertical shift? Is there a vertical shift? Yes, the graph moved up or down? No. There is a horizontal shift, right? There is a horizontal shift, but there is no vertical shift. So I'm going to put 0, which means that my k value is 0. This graph is right in the middle. The midline is 0, right? The midline is 0. This is right in the middle, okay? In fact, oh no, we do have a couple with vertical shifts. Okay. All right, so now we're going to go ahead and we're going to write a sine equation. So I'm going to say y equals, and we're doing a sine equation because that's what I highlighted, right, when I did my marker. So I'm going to say y equals, we got 3 for our amplitude. I'm going to say sine. I'm going to have my big set of parentheses. I'm going to have my little set of parentheses, right? And then what goes in front of my little set of parentheses? 2 for my b value, okay? Did my graph shift to the left or to the right? To the right, so I'm going to say x minus, and how far did it shift to the right? It shifted to the right pi over 6, okay? All right, and then what's on the end here? Plus 0, or you could say nothing. I'm going to put a plus 0 just because these are my notes. And so it's nice to know where all the numbers went. Okay, if this is 1/6 and this is 7/6, what's in the middle of 1/6 and 7/6? Wait. 4/6? 1, 2, 3, 4, 5, 6, 7, 4/6. Okay, 4/6 is right in the middle. Okay, and if we've got 1/6 and 4/6, what's right in the middle of that? What's this going to be? Not 2/6. Not 3/6. It's 1.56. Okay, right, because it's in the middle of 2 and 3. Do you guys agree with that? Okay, let's fix that fraction because we're going to have to make that not a decimal over a fraction, right? So we're going to say this is, what's 1.5 as a fraction? 3 over 2. So we're going to say this is 3 over 2 over 6, which is what? I think somebody said it. 3 over 12? 3 over 12, do we agree with that? Yeah. 3 over 12. So when you have a 2 that's divided by a 6, or when you're dividing by a 6 is the same thing as multiplying by 1/6. Okay? Do I need to walk through how I did those fractions again? So we're just making sure that we can figure out what was the benefit of me doing all of this? Why did I do it? What's my purpose? Yeah, and I'm not finding a new period. I already know the period of the graph. I'm trying to figure out where it starts. Do you guys see that? I'm trying to find a good starting point for it. So I've got one, I can say this is where it starts, or I can say this is where it starts. I could also say this is where it starts, right? I already know the amplitude, I already know the period, I already know the vertical shift, but I have to figure out where it starts for me to be able to write my cosine graph. No matter what, I'm going to have a hard fraction to work with. So I have to figure out some way to figure out what the middle is. So if I know that this is pi 6 and this is 4 pi 6, then I can find the middle. Does that make sense? So when we work with these today, we're going to be working with some fractions that are a little bit uncomfortable. So we have to remember how fractions work. Okay? So 1 and 7, the middle of 1 and 7 we said was 4. The way we can find the middle of those two is we can say 1 plus 7. Right, this is just averages. How do I find the middle? I add them together. 1 plus 7 divided by 2 is 4. Does that make sense? 1 plus 7 divided by 2 is 4. 1 plus 4, or now to find the middle of these, 5 halves. Is that where we're at? I wrote 1.5, but this should be 2.5. 5 halves? Right, I said between 2 and 3. I wrote 1.5, but I meant 2.5. It was between 2 and 3, so it should have been 2.5 over 6. We knew it was a half. I just wrote down the wrong one. So to find the middle of these, we're going to do 1/6 plus 4/6 is 5/6. Divide it by 2. What's half of 5? 2.5 over 6. Does that make sense? So finding the middle, we add them together, divide by 2. 2.5 over 6. So 5 halves divided by 6, we're going to say is 5 over 12. 5 twelfths. How do your brains feel? We're going to do it again. This is only example 1. Okay? So now let's go ahead and write the equation for cos. So I'm going to trace this. This is going to be our cos graph. We're going to say, now this is not a different one than the sine graph. I'm just saying that it starts right here instead of starts over here. I'm just going to say it starts in a different place. Okay? So, do we have a positive or a negative cos graph? Is what I drew positive or negative? Positive. It starts high. Okay, that's positive. Positive 3 cos. Okay, still has the same period, so it's still going to have a 2. Did it move to the right or the left? To the right. Okay, x minus. All right, and then how much to the right did it move? How much to the right did it move? 5 pi 12ths. 0 on the end. Okay? Now today, if we want to check our answers, we have 2 options for checking our answers. We can check them in a graphing calculator, or we could check them on Desmos. I would be okay with you guys using Desmos if you prefer that. But what we should be able to do, and let's all do this on the graphing calculator so we can see how to check these. Say that again? Where are the graphing calculators? And they didn't bring them back?
Yeah, they're over there. They're on the floor beside the fire extinguisher.
In my black box? They've just been sitting over there? Okay. Let's go ahead and let's nose goes and have somebody go grab graphing calculators for the group.
They gave us the white. They gave us the white calculator. Because they couldn't give me.
Yeah, that's obnoxious.
And they gave me the. I didn't have that one. I had the freaking white one, but I didn't know how to use them. And then they gave me Desmos, and I barely remember how to use that one.
They gave you guys Desmos on the ACT?
Yeah, it was like since it was online, it was like one that you could click on. They said they're switching both to online now, so I guess we couldn't be able to use both. Yeah, it was up at the top. It was their graphic card.
On ACT?
Yeah, it was on there.
That's weird. Okay. Okay. All right, everybody have a calculator? Okay. Before we get started, we're going to do second plus 712. Second plus 712. Okay. And now we're going to hit y equals, and we're going to start typing the equations. So I've got 3. I'm hitting the sign button. Since we cleared the memory, our calculator is back in radians. Are those calculators dead or something? You want to bring it up? Yep. Okay, so I've got 2 parentheses x minus pi divided by 6. You don't have to type in the pi over 6 as a fraction. You can type it in as division. You don't have to put in the plus 0. Now, what I'm going to do is I'm going to type these both in at the same time because these are describing the same equation. So I shouldn't see 2 graphs. I should only see 1 graph. Cos 2 x minus 5 pi divided by 12, parenthesis, parenthesis. Yep, okay. Now, when I go to window, I'm going to change my window so that it looks like this. Okay? Because I want it to look about the same. So for my x max and my x min, I'm going to have this go from like negative pi 6 over here to 7 pi 6, 8 pi 6 over here. So my x min, I'm going to do negative pi divided by 6. See how I typed it? Negative pi divided by 6. As soon as I press enter, it's going to turn this into decimals. Okay, as soon as I go down to the next line, it's going to turn it into decimals. So negative pi 6 and then 8 pi 6. For my scale, you can see that each of these, since it says pi 6 right there, each of these little dashes is going by pi 6. So I don't want to go by ones because that's going to confuse me. It's going to be a different scale than what's on my paper. So since my paper goes by pi 6, I'm going to have my scale go by pi 6. Everyone see that? Okay. Now for my y's, my y goes down to negative 3. It goes up to positive 3. So I'm going to go down to negative 3 and up to positive 3. So negative 3 to positive 3. My scale for the y's goes by 1. So I'm going to leave my scale as 1. So whenever I graph trig functions on my calculator, I always try to change my window to mimic whatever graph I have on my paper so that it can look about the same. And then once you have this typed, once you have the window about the same, you can hit the graph button, and then it should look about the same. And even though I can see these showing me it's still graphing, it's graphing another graph right now, I shouldn't see another graph because it's graphing the same thing twice. It's graphing the sine version of it, it's graphing the cosine version of it right on top. For the window, I did negative pi 6 for the x min. I did 8 pi 6 for the x max. For the x scale, I did pi 6. So I'm just looking at the picture and I'm doing the same window, the same intervals that you can see in the picture on your paper. And then for the y min, I did negative 3. For the y max, I did positive 3. And for the y scale, I did 1.
What was the x min?
So for the x min, I did negative pi 6. For the x max, I did 8 pi 6. And then for the x scale, I did pi 6. Okay. All right, that's only the first one though, so we got some more examples. How do we feel? Okay. It's long. It gets easier. Now, truly, the worst part of this, you guys, was finding the 5 pi 12ths. That was the worst part. The rest of it, you guys seemed like it was pretty easy. The worst part was the 5 pi 12ths. The second worst part was figuring out the window so we could check our answer. Okay, so it will get easier. Okay, let's try another one. So do you guys want to do a sine graph or cosine graph first? Sine first? Okay, let's grab our marker. And is it okay if I start right here at the beginning? Does that work? Okay, so I'm going to start right here. And I'm just going to do one shape of the graph. Yeah, it looks like pi. Okay. So the amplitude is 4. The period of the graph is pi. So if we have 2 pi over b equals pi, then that means that the b value is 2. Okay. Is there a vertical shift in the graph? What's the midline? The midline is 0, so there is no vertical shift. Okay. Is there a phase shift in the graph, meaning did this graph go left or right? No, it did not. Okay, so I'm going to write y equals, did the graph start right side up or did it start upside down? Started right side up, so I'm going to write y equals positive 4 sine 2 x, And then I don't need anything in parentheses because the graph didn't go right or left. I don't need anything on the end because there's no vertical shift, although I could put a +0 to show that the midline is 0 if I wanted to make it easier to see. Okay, so if this is pi and this is 0, what's right in the middle? Pi halves. Okay. If this is pi halves and this is 0, then this would be pi fourths. If this is pi halves and this is 1, what is this? 3 pi fourths. Okay. Now, when I draw these graphs, I almost always do shifts to the right. I typically don't do shifts to the left because then I have to do like, oh, it went in the negative direction. But if this is pi fourths, does anyone know what this is? Yeah, negative pi fourths. It just went pi fourths to the left. We could do that one too. Okay. So do you guys want to say it went pi fourths to the right? Do we want to start here? Do we want to say it went 3 pi fourths to the right? Do we want to say it went pi fourths to the left? Where do you guys want to start your cosine curve? Pi fourths to the right? Oh, so boring. It's fine. It's fine. We can do it that way. Okay, so let's start up here. And we'll draw our cosine curve. Okay. Now with the cosine curve, we're going to have the exact same amplitude, exact same period of the graph, exact same vertical shift. The only difference is how far it shifted to the left or to the right. Okay, so let's go ahead and start writing the equation. What do we have? Okay. And it shifted to the right, so are we going to have a plus or a minus? Minus. And how far to the right did it shift? Pi fourths, okay. And then vertical shift on the end, you can put a +0 on the end or not put a +0 on the end. It does not matter. Okay, now if we want to check our answer on here, I'm going to go ahead and clear off the two equations that I had previously typed in. Type the new equations in. 4 sine 2x plus 0. 4 cos 2 parenthesis x minus pi fourths. Okay. Now for my window, looks like the furthest to the left that I went was negative pi fourths. Negative pi fourths. To the right, I did, oh, not pi fourths. Sorry. What is that? Pi halves. Let me go back up. Negative pi halves. Okay. This is 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, that's 2, and then 5 pi halves. That's how far it went to the right. Does everyone see that? So 5 pi halves is how far I'll go to the right. 5 pi halves. And then each individual line is just pi halves. So for my scale, I'm going to do pi halves. Do I need to repeat any of these for how I did my window? For my y, what should I do? Negative 4 to 4. And then what should my scale be? 1. It went by ones. Okay. So we'll go ahead and graph this, and it should look exactly the same. Okay, and it looks, so this one, they didn't draw the extra loop, but if they did this part, then we would have seen that. So we could go back to our window, we could stop it at 2 pi, because that's where they actually stopped drawing it, even though the markings went a little bit further. They stopped drawing it at 2 pi. 2 pi and a fourth, it looks like, maybe? Stop drawing, anyway. But the loops are all in the places where they should be. Okay. And a good sign that we only have one drawing, even though we put 2 equations in, that means that our 2 equations match each other. They're exactly the same equation. Okay, let's try the next one. Sine first or cosine first? Sine first, okay. All right, I'm going to make things difficult. I'm going to start right here. So, can you guys tell what the amplitude is? 3? 1, 2, 3. Yeah, 3. The period of the graph is, so this is 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so it goes from 2 to 6. So the period of the graph is 4. So we have 2 pi over b equals 4. And we're going to have to solve for b. So I'll multiply the b up here. I have 2 pi equals 4b. How am I going to solve for b? Divide by 4. So b equals 2 pi over 4. B equals pi halves. Okay, b equals pi halves, which fits what our experience has told us, that anytime the b value has a pi in it, that's when the period of the graph does not have a pi in it. Okay, is there a vertical shift here? Nope, so that's just going to be 0. Okay, are you guys ready to write the sine equation? So y equals negative, since it goes down first, negative 3 sine so what should I put in here? Not 4. Pi over 2. Pi over 2, which gave us 4, right? And then, did the graph shift to the right or the left? To the right. So we're going to say x minus, and how far to the right did it shift? 2, x minus 2, and then what goes on the end? Plus 0 if you choose to put it, or you could leave it out. Okay, let's choose a cosine equation. I'm going to force you guys to choose a more interesting one, so we're going to do this one right here. There's our cos equation that we're going to do. Now, we know all the information is mostly the same. What is different? Yeah, how far it shifts is the only thing that's different. The amplitude is the same, the period is the same, the vertical shift is the same. The only difference is the horizontal shift. The phase shift is going to be different. And then whether or not there's a negative in the front could be different, or it could not be different. It depends on how you choose your equation. Okay? So for this cosine graph, what are we going to say? Negative 3, this is a negative cos graph. Negative 3 cos pi over 2. Did we go to the right or the left? Left, so I'm going to say x plus, we went to the left 1 box, plus 1. You can put a 0 on the end or not put a 0 on the end, okay? And if we want to check our answer and make sure it's good, I'll go ahead and type both of these in. And what should I do for my window? What should I do for my x min and my x max? -2 to -2 to 8 would be great. Yeah, that's what I can see. -2 to 8. What should my scale be? Go by ones. It goes by ones. Okay. What should I do for my y's? Okay, -3 to 3, and I should go by ones. Okay. And it looks just like the graph, and it only graphed one curve, which means our equations match, and it matches what was on the paper. All right, how do we feel about these?
Good.
Feeling pretty good? Okay, let's flip the page. All right, this one is all spread out. Now this one, they specifically showed you one of the types of curves. They didn't really show you the other one. It's there, but they didn't really show it to you. Which one did they show you? Sine or cosine? What did they show you? This looks like a sine curve, right? So we're going to find sine, and then from sine, we're going to get enough information to deduce what the cosine curve could be. All right, so there's the sine curve. What is the amplitude? So it looks like it goes by ones. They said that's one, that's one. Okay, so it goes by 1, so the amplitude is 1. The period of the graph is how many boxes? 8. So we have 2 pi over b equals 8. So 2 pi equals 8b. Divide by 8. The b value is pi fourths, okay? What is the vertical shift? Up 3, positive 3, okay? So the sine equation is what are we going to write for the sine equation? Sine. Oop, we don't even need the parentheses. Okay, not 8. We need pi fourths x plus 3. Okay? All right, now for the cosine equation, we're not going to go to the left. We don't even have a graph there. Do you guys want to start it up here, or do you guys want to start it down here? At the top? Okay, I'm not going to be able to draw all of it, but you can kind of imagine it would end up over here somewhere. Okay? So for the cosine equation, I'm going to say y equals cos pi fourths, okay. It moved 2 to the right, okay. Plus 3. Okay. How confident do we feel in our answer? Pretty confident? Do we want to check it on the calculator or just move on? Move on? Yes. Why is it x minus 2? Why is the amplitude 1? Because from the middle of the graph, the middle is 3, the midline, it goes up to 4 and it goes down to 2. So it's a distance of 1 away from the middle. And so that's the amplitude. Okay, let's try the next one. All right, do you guys want to do the sine equation first or the cosine equation first? Sine? Do you guys see how maybe the cosine equation could be easier to do first? Should we do the cosine equation first? Yeah? Okay. So okay, so I'm going to do it like that. So what is the amplitude of the graph? 2. So we got the middle, and then we have how far it goes up from the middle, how far it goes down from the middle. So amplitude of the graph is 2. What's the period of the graph? Pi fourths. So 2 pi divided by the b value is pi over 4. Okay, so if we have a fraction equals a fraction, what should we do? What if we couldn't naturally see that it was 8? If we have a fraction over a fraction, or a fraction equals a fraction, what should we do? You can cross multiply? Yeah, middle school teachers are really good at teaching this. So 2 pi times 4 equals b times pi, right? And so we've got 8 pi equals b pi, and so b equals 8. Okay. All right. Yeah. Your vertical shift is 3. Okay, so let's write down that cosine equation. Y equals it's the middle. You're close. Negative 2 cos. Oh, we did not do left or right. Negative 2 cos, and then what? Negative 2 cos 8x plus 3. Okay. All right. So if this is pi fourths, the middle is pi eighths. Okay. The middle of that is pi eighths. Okay. Now from here to here, if this is pi eighths, the middle of that is pi sixteenths. Okay, are we all right with that? So this would be 1/16, 2/16, 3/16, 4/16. Does that fit? Okay. All right. So do you guys want to start your sine graph at 1/16 or 3/16? 3/16? Or 1's fine. What do you guys want to do? 1/16 or 3/16? 3/16? Yeah, let's make it fun. Okay, so I'm going to label this on my picture just so these are really good notes. Okay. So my sine equation is going to be what? Positive or negative? Negative 2 sine uh-huh 8 uh-huh 3/16. Okay. Okay. And then if we want to feel good that we got this one right, so for my window, I've got 1/4, 2/4, 3/4, 4/4, 5/4 is what I'm pretty close to. I'm not quite there, but I'm pretty close to it. So I'll do 0 to 5/4. My lines go by 1/4. Down here, it looks like I go to, not quite to 6. I'll go ahead to 5. So I'll do -1 to 5, and I'll go by 1s. So my graph is starting right there. Yep. And it's still graphing, but I'm not seeing another graph. That's a good sign. So up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, same graph. Whew. Isn't that satisfying when you get it right? Nobody? Nobody? Huh? Okay. Last one. One more. All right. For this last one, you guys want to do a sine curve or a cosine curve? What's easiest based on the picture? Sine or cosine? Look at the picture. Where do you see a full period of the graph? Sine curve or cosine curve? Full period of the graph. Full sine curve. So I can see that the cosine curve starts here, but do I get a full cosine curve? No. So I can see a sine curve starts here, which is on the left. That makes me less comfortable, but I can see the whole thing at least. Does that make sense? So I want to start with a sine curve because I want to be able to see the whole period of the graph so I can at least figure out what the period of the graph is. So I'm going to start with a sine curve just because I can see the whole thing. So there's a little bit of strategy involved here. So I typically go with a sine curve. Every so often I might have a problem like number 5 where I do a cosine curve instead. Just kind of depends what information they gave me. Okay, so problems like this, cosine curve maybe. Problems like 4 and 6, sine curve is kind of what we have to do. Problems like these, maybe you can kind of choose. Maybe you can decide which one you want to do. Yeah. Okay, so from -6 all the way to 18, the period of the graph is 24. Yeah, 18 plus 6 is 24. 24 pi. So if we have 2 pi divided by b equals 24 pi, I'm going to multiply the b over there. So 2 pi equals 24 pi times b. It was 18 pi right here plus 6 pi over there. And altogether that's a width of 24 pi. Mm-hmm. It goes all from here to here. So I'm going to solve for b. I'm going to divide by 24 pi, divide by 24. Oops. So 2 over 24 is 1/12. So 1/12 is b. What's the amplitude of the graph? 2? Is there a vertical shift? No. Okay. So let's start writing the sine equation. Y equals 2 sine not 24, 1/12. Okay, did the graph shift to the left or to the right? To the left. Okay, so I'm going to put a plus here. And how far to the left did it go? 6 pi. So plus 6 pi. Okay. Is there a number on the end? No, it's 0. Okay. For the cosine equation, now this is where I can say, okay, let's start right up there. It would end somewhere over here. Okay. So my cosine equation is going to be y equals 2 cos 1/12 x. Did the cosine graph shift to the left or the right? Did it shift up or down? No. Okay. All right. How do your brains feel? Can be different depending on where you start. Yeah. Yeah, you could have started this cosine equation. We could have started right here, and we could have said that this graph was negative 2 cos, and we could have said it shifted to the right 12 pi. We could have done that. Mm-hmm. Yeah, so this is going to be one of those where when you check the answer key, if it's one like this, it might not match mine because maybe, so what I'm going to do is I'm going to anticipate on questions like this what most students would probably do. But if you're getting bored of like the typical answer and you start like mixing it up a little bit to entertain yourself, then your answers may not match. Does that make sense? So they might be just a variation of something else. Yeah. Kind of like how we decided to do 3/16 on this one, even though 1/16 is what most people would probably do. Yeah. Good question.